like we talked about in class, you guys have other notes for 5-4. And they have some problems a couple problems that are a little bit more advanced. And so these are a little bit more basic. Same skills, you can watch either video. You can use the other 5-4 slides in video, which have already been posted, or you can use these 5-4 slides and these videos. Part 1 will focus on exponential functions, and Part 2 will focus on logarithmic functions, just like the other slides. So if you're solving exponential equations, remember that we talked about how certain things in math undo each other. Subtraction undoes addition, multiplication and division undo each other, roots and exponents undo each other, and logarithms and exponential functions, they can undo each other. And so what we mean by that, first is you have some basic problems, right? Like, for example, the one-to-one property, you learned that if you have, 3 to the x power equals 3 to the 5th power, if the bases are the same, you can cancel them and you can make the exponents equal to each other, and that's great. However, sometimes you can't do that. Sometimes you have a problem let me give you another example of when it does work. Like 2 to the x equals 8, so you can convert 8 to 2 to the 3rd, cancel your base, and x equals 3. And again, you're able to solve by changing to the same base and then canceling out the base. But what happens if you have a problem where you can't do that, right? What happens if you have a problem like, let's say, 2 to the x equals 18, and you're like, I can't convert 18 to a base of 2 to some power, right? Because I know that 2 to the 4th power is 16, and I know 2 to the 5th power is 32. So 2 to the 8th, or 18, has to be somewhere between 4 and 5, but it's going to be a decimal. And so how do I solve that? Well, we have a trick for you, or a rule, or a method of solving. And what happens is I can create a log with the same base as this. So if this is 2, I do log base 2. And so you might say, well, why do we do that? Well, because log base 2 of 2 cancels, and it frees up the exponent at the top. The only issue is that I need to do the same thing to the other side. So log base 2 of 18. So if I insert log base 2 on the left, I have to insert log base 2 on the right. So now I have x equals log base 2 of 18. Now some of you may have a calculator where you can put base 2 of 18 and solve it. Most of you do not. Most scientific calculators only use common log, which is log base 10, or natural log, which is log base e or ln, right? So if I want to change the base here, I could do common log of 18 over common log of 2, or I could do natural log of 18 over natural log of 2. And either way, when I do the math, I'll get that answer, which is x equals approximately 4.17, which makes sense because we calculated it's somewhere between 4 and 5, and that makes perfect sense. It's in the range. Always check your range. So we're going to do some problems now, all the same thing. Now, of course, anytime you can change the base to match, that's what you're going to do. So 100 on the left and 1/10 on the right, I know that 100 is equal to 10 squared to the x power, and I know that 1/10 is 10 to the negative 1 raised to the x minus 3 power. And if you notice, this was 100 and this is 10 squared. They're perfectly equal. This was 1/10 and this is 10 to the negative 1. They're perfectly equal. I'm not changing the value of what's being raised to the x or the x minus 3 power. Now what I do is I do my powers to powers and I multiply the 2 times the x, and over here I multiply the negative 1 times the x minus 3. By doing this, I've freed up the base of 10 and I can now cancel it out. So 2x equals negative 1x plus 3. I'm distributing. Add x to both sides. 3x equals 3, and divide both sides by 3, and I get x equals 1. And so that's my solution. Now, when I go to the right side, I can't do the same thing. I can't make the bases the same. And so for the right side, what I'm going to do is I have 2x over here, I have 7 over there.
Excuse the interruption.
And so here what I have to do is I have to do log base 2 and log base 2. The log base 2 helps me to cancel that 2 out. And so now I've got x equals log base 2 of 7, which again, I'm going to convert to natural log of 7 divided by natural log of 2, and I'm going to get approximately equal to 2.807. And that makes sense because, again, remember, guys, that 2 to the second power is 4 and 2 to the third power is 8. So it definitely has to be a number between 2 and 3, closer to 3. And so 2.807 makes a lot of sense. Again, we'll just do more examples of the same. Over here, I'm going to do log base 2 of 2 to the x power equals log base 2 of 5. This cancels, and I get x equals log base 2 of 5, which I use natural log because it's easier to write. No other preference, really. So I know that my answer is 2.322. I come over to the next problem, and of course I'm going to be doing log base 7. So log base 7 of 7 to the 9x power equals log base 7 of 15. These cancel, 9x equals log base 7 of 15, and I'm going to divide that total by 9 because, again, I'm trying to find x. So I have to be very careful here. Log base 7 of 15 over 9. Remember, log base 7 is the same as natural log of 15 over natural log of 7, all divided by 9. So you have to be really careful when inserting this into your calculator. I'll start with my numerator. And when I do natural log of 15 divided by natural log of 7, I get 1.392, and then I'll divide that by 9. And then my answer will be 0.155. So I take my time and I, do parts first, okay? Some calculators are really good about, having numerators and denominators and fraction bars, but most are very linear. You have to go and use parentheses and stuff, so I don't recommend it. I recommend solving your numerator first, solving your denominator, and then doing the division last. Last question for here, number 3. Again, here, I know that what I'm going to want is e to this negative 0.3x power by itself. So I'm going to start chipping away. I'm going to start by adding 7 to both sides. So I'm going to get 4e to the negative 0.3x power equals 20. And then I'm going to divide both sides by 4. So e to the negative 0.3x power equals 5. And so here I'm at this point, so e to some power equals 5. Well, I'm just going to insert log base e to both sides. So over here, this is going to become log base e of the 5. Sorry about that. Okay, so again, the log base e and e will cancel, negative 0.3x. And over here, I'm going to write ln 5 because it's a little easier than log base e. And then I realize, well, if I'm solving for x, I have to divide both sides by negative 0.3. That cancels, right? Leaving me with the answer. So it's going to be the natural log of 5 divided by negative 0.3. And I'm going to get 5.365. Okay, now if I'm ever in doubt, because that one was kind of tough, right? I can always plug it back in and make sure that the math works, right? So, I can think about that. I can do 5.365 times 0.3 negative. I'm going to get negative 1.6 power, so I'm going to do e to that power. It's going to give me a negative 5. I'm going to multiply it by 4. Negative 20, and then I'm going to do, or positive 20 rather, and then I'm going to do minus, yeah, and it works. So again, plug it back in and make sure that the math works. There's no harm in that, especially when it's worth points, right? So we've come to an end of part one, okay? Remember, part one was just exponential functions, and so this is how we solve that. Now I'm going to continue the video, and I'm going to do the logarithmic functions. So now we're in part two, okay, where we're solving logarithmic functions or equations. And again, we realize when we have the equations, when we get it to a single log on the left that matches a single log on the right, we can cancel them out. And the of parts sort of equal themselves, and that's great. So we don't always get it in this form, though. Sometimes we get it in a form that we have only a log on one side, or maybe we have multiple logs, and so we want to go over the process of how to do that when you have multiple logs. So here, in example A, we don't have an example of that yet, right? In A, we have the natural log of 4x minus 7, and over here it equals the natural log of x plus 5. Again, since it's only one log on each side and they match, we can cancel them, and the of parts equal themselves. So here I'll have to subtract x from both sides, so 3x minus 7 equals 5. Add 7 to both sides. 3x equals 12, and divide by 3, and we get that x equals 4. So again, this is just like solving a linear equation, super easy. What happens when we get to a problem B, though, where we have a log on one side, log base 2 of 5x minus 17 equals 3? Well, we can solve this two ways, okay? Method one is to rewrite as an exponential function. Rewrite as exponential, okay? Which means we learn how to do that. We take this to the third power, so the base to the third power equals the of part, 5x minus 17. So you do the math. 8 equals 5x minus 17. You add 17 to both sides. 25 equals 5x, and you divide by 5. And you get that x equals 5. And there's your answer. Method two is going to get you it's going to get you to the same place, okay? This was method one. What you're going to do here is you're going to insert a base to both sides. And you're like, what do you mean by that, right? And you don't really have to do it. Again, method one works, but let me show you how that's done. So you started out here with log base 2 of 5x minus 17 equals 3. Well, what we're going to do is we're going to take this whole log and we're going to turn it into an exponent with a new base. And the base we're going to give it matches this base, 2. And we're going to do the same thing to the other side. We're going to turn it to an exponent. We're going to give it the same base, because whatever we do to the left, we do to the right. Look what happens. 2 to the log base 2 power, remember that's a property. We learned that that cancels out, leaving you with just the exponent. And then over here you have 2/3. So again, notice not 2/3, but 2 to the third power, right? Minus equals 8. Again, you add 17 to both sides, and x still equals 5. So we're going to get to this, okay? It's just we insert this step and we get there in a different way, but it works. And I'm going to kind of do both for you. I'm going to do both to make sure that you see both ways. So again, we come over to here. Let's look at this problem. This problem actually has 2 logs on the left. Well, before I do anything, I have to combine them or condense them. And I know that when I have addition, condensing relates to multiplication. So it's going to be 2x times x minus 5 equals 2. Now remember, this is like a base 10. So now that I have it as one thing, I can either do method 1, which is to rewrite it. 10 to the second power equals 2x times x minus 5. Or what I could have done is I could have done the same thing. Let me write it over here. I could have had, again, log base 10, 2x, x minus 5 equals 2. And I could have done 10 to this power and 10 to this power. And when I did that, I would have gotten 2x times x minus 5 equals 10 squared. Notice they're the same. Whatever method you want to employ. At this point, I'll just do the math here on the left. I've got 2x squared minus 10x. And I notice a quadratic, so I'm going to have to solve a quadratic, which means move everything over to the same side. And because they're all divisible by 2, I'm going to do that just to make my numbers smaller. 0 equals x squared minus 5x minus 50. I'm going to factor x minus 10, x plus 5. That's weird how dark that got. Okay. And x equals 10 and x equals negative 5. So now I got two solutions. I have two solutions here, and I have to evaluate, are they both valid? Well, you have to check for extraneous. And what we mean by that is one of these answers mathematically sound, but in this problem it doesn't work, okay? And how that works is you cannot, this of part, the 2x, the x minus 5, in a log, the of part must be positive, okay? Must be a positive number. So no negative and no 0, okay? It can't be this, when I plug x in, that can't equal negative number and it cannot equal 0. So when I take 10, 2 times 10 is 20, it works, right? So 2 times 10 and 10 minus 5. That's positive, not equal to 0. This is valid. But if you notice, when I come back over here and I plug in negative 5, 2 times negative 5 is a negative number. I don't even need to check the rest. It's done, okay? It doesn't work. So the only valid solution here is 10. So here we have just a bunch of them. We're going to do them all, okay? So number 5, it's like an example of all the different ones. Number 5 is natural log of 7x minus 4 equals natural log of 2x plus 11. It's single log, so I can cancel them. 7x minus 4 equals 2x plus 11. Subtract 2x from both sides. I'm going to get 5x minus 4 equals 11. Add 4 to both sides. 5x equals 15. X divide by 5, x equals 3. And double check that 3 does not make any of these negative, and it doesn't, so it's valid. Okay? Number 6 is a little different. Number 6 is a log on one side, and this is where, again, you have two methods. I'm just going to do the exponential. 2 to the 5th power equals x minus 6. 2 to the 5th power is going to be 32. So I'm going to add 6 to both sides. 38 equals x. And there's my answer. And again, 38 minus 6 is 32. That's positive, so it's valid. We go to number 7. I don't know why it changes thickness. Sorry, guys. It's weird. I have log of 5x. Sorry about that little dot I put there. It's not necessary. Log of 5x plus log of x minus 1 equals 2. I'm going to start by condensing. Now, this is log base 10, if you're wondering, but it's going to be 5x times x minus 1 because that's addition equals 2. So now I'm going to rewrite it. 10 squared equals 5x times x minus 1. 100 equals 5x squared minus 5x. Again, distribute. It's a quadratic, so I'm going to subtract 100 from both sides. And I'm going to divide everything by 5 because I want to simplify this to the smallest numbers possible. And then it makes it super easy to factor. X minus 5, x plus 4. So x equals 5 and x equals negative 4. And then I'm going to check for extraneous. If I go back to this problem and I plug negative 4 in, that makes this negative 20, which makes it invalid. So negative 4 does not work. When I try 5, 5 times 5 is 25, and 5 minus 1 is 4. It's both positive, so it's valid. So x minus 5 is my only answer that's acceptable here, okay? And last but not least, let me do number 8. I've got log base 4 of x plus 12 plus log base 4 of x equals 3. Again, I have to condense the side first. X times x plus 12 equals 3. Rewrite it as exponential, so 4 cubed equals x times x plus 12. 64 equals x squared plus 12x. Again, I've got to set it equal to 0, so I have to subtract 64 from both sides. And then I have to factor. And so 64 is going to be positive 16. Oops, I don't know what I'm doing there. Positive 16 and negative 4. Right? What numbers multiply to minus 64 and add up to 12? 16 and negative 4. So x equals negative 16 and x equals positive 4. And again, I'm going to check for extraneous. I already know right here, if I plug negative 16 in, that makes it a negative, so it's not good. And when I do the 4, 4 plus 12 is 16, that's good. And 4 is just 4, so that's good too. So 4 is the correct answer. So again, guys, there's another video with more examples if you want, and you can go back and do that, but I wanted to make sure to open this up for you.